Your car is not broken. It's restricted on purpose. Manufacturers build engines that can last 300,000 miles, pull hard, and run like a dream. Then they quietly choke them with lifetime fluids, fake maintenance intervals, and soft, sluggish settings that keep you coming back to the dealership. After years in the shop, I can tell you this. Your car is capable of far more than the manual wants you to believe. In this video, I'm revealing 10 illegal tricks mechanics use on their own cars to make them run smoother, stronger, and longer. Tricks you will never see in a glossy brochure. We're talking about methods that wake up lazy throttle response, restore lost power and MPG, prevent thousands in mysterious repair bills. Some of these go directly against the manufacturer's recommendations. Some will absolutely get a dealership service advisor fuming if you mention them. And one of them, near the end of this video, can turn a lifetime transmission into a 200,000-mile survivor for less than the cost of a tank of gas. If you're tired of driving a car that feels older than it really is, hit subscribe now and stick with me. Because once you know these 10 tricks, you'll never look at factory recommended the same way again. Trick number 10, the lifetime transmission. Fluid myth manufacturers don't want you questioning. If you read through your owner's manual, you'll probably find a line that looks harmless at first glance. Transmission fluid, lifetime fill. Most people see that and feel relieved. No service, no maintenance schedule, nothing to think about. Just drive forever and let the transmission take care of itself. But after years working in the industry, I can tell you this confidently. That statement is one of the most misleading claims in modern automotive maintenance, and it quietly contributes to more transmission failures than anything else. Transmission fluid isn't magic, it's oil. Oil breaks down under heat, friction, and contamination. Inside the transmission are dozens of precision hydraulic passages, clutch packs, tiny bearings, and valves operating under extremely tight tolerances. As the fluid ages, it loses its viscosity, shear strength, and thermal stability. It begins picking up microscopic metal particles from the clutch plates and gears, turning into a dark, abrasive mixture that slowly accelerates internal wear. Eventually, drivers begin to notice delayed shifting, shuddering under acceleration, or a faint whining sound that wasn't there before. By the time symptoms are obvious, most transmissions are well on their way to a multi-thousand-dollar failure. So, why do manufacturers claim the fluid lasts a lifetime? Because lifetime doesn't mean the lifespan of the vehicle. It means the duration of the warranty. If the transmission survives past that window, its failure becomes financially your responsibility, not theirs. The real solution is simple. Perform a drain and fill every 30,000 to 40,000 miles. Unlike a high-pressure flush, a drain and fill gently replaces a portion of the fluid without shocking the system. It's inexpensive, requires no special equipment, and dramatically reduces long-term wear. Transmissions that receive scheduled fluid changes routinely last 180,000 to 250,000 miles or more, while those following the lifetime claim frequently fail before 100,000. Once your transmission is protected, the next weak link to eliminate is the oil interval lie, and that one affects nearly every modern car on the road. Trick number 9, the oil change interval trap that slowly damages modern engines. If you rely on the maintenance reminder on your dashboard or the interval printed in the owner's manual, you may believe your car only needs an oil change every 10,000 to 15,000 miles. It sounds modern, efficient, and convenient. And that's exactly why manufacturers advertise it so confidently. A vehicle that appears low maintenance is easier to sell, especially to buyers who assume fewer services mean better engineering. But after years working in the field, I've seen what truly happens when those extended intervals are followed literally. And the results are almost always the same. Accelerated wear, internal sludge, premature timing, chain deterioration, and eventually engine failure that coincidentally appears just after the warranty expires. Oil doesn't simply lubricate the engine. It cools internal components, suspends contaminants, reduces friction, and protects moving parts from metal-to-metal contact. Every combustion cycle creates moisture, carbon, acids, and microscopic metal particles that the oil must hold until the next service. Under ideal, controlled test bench conditions, oil can last the distances manufacturers claim, But real-world conditions are nowhere near ideal. Short trips, stop-and-go driving, long idle periods, cold starts, dusty environments, and temperature extremes all qualify as severe service driving. And according to the EPA, over 87% of drivers fall into that category without realizing it. In severe service use, oil degrades twice as fast, meaning that a scheduled 10,000-mile interval effectively becomes the equivalent of running 20,000 miles between oil changes. That is when varnish begins forming on internal surfaces, piston rings lose sealing efficiency, and sludge gradually blocks oil passages. The fix is straightforward. Change conventional oil every 5,000 miles and full synthetic every 6,000 to 7,000 miles, paired with a high-quality filter instead of the cheapest option available. This small adjustment can extend engine life dramatically, reduce wear, and eliminate the type of preventable mechanical failures many owners wrongly blame on the car itself, rather than the interval that maintained it. With fresh oil protecting the engine, the next system to optimize is the source of ignition, and that begins with something tiny that most people never check. Trick number 8, the spark plug, gap adjustment that restores power manufacturers don't mention. Most drivers never think about spark plug gap, and manufacturers take advantage of that. The common belief is that spark plugs are pre-gapped from the factory and ready to install straight out of the box. No inspection, no adjustment, no thought required. On paper, that sounds reasonable, but in practice, it's rarely true. After years in the shop, one pattern has repeated itself constantly. Factory plug gaps are often slightly out of specification, and that small discrepancy is enough to affect performance, fuel economy, and throttle response, especially as the plugs begin to wear. A spark plug's gap determines how much voltage is needed to fire the spark. If the gap is too wide, the ignition system struggles to generate a strong, consistent spark under load, which can result in hesitation, weak acceleration, and incomplete combustion. If the gap is too tight, the spark may occur easily, but combustion efficiency decreases and emissions increase. Manufacturers generally choose a setting that prioritizes emissions compliance and long-term safety margins, rather than optimal power and responsiveness. Over time, electrical erosion naturally widens the spark plug gap, often by several thousandths of an inch. Even a small increase affects firing strength. Drivers begin noticing a rough idle, reduced fuel efficiency, and sluggish power delivery, while assuming the engine is simply aging. Dealerships frequently use this moment to recommend new plugs or, in some cases, coil replacements, repairs that can cost anywhere from a few $100s to well over $1,000, depending on the vehicle. The mechanic approach is much simpler. When installing new plugs, verify the gap with a simple tool and adjust it to the tighter end of the manufacturer's acceptable range. This ensures a stronger spark and more controlled burn inside the combustion chamber. The result most drivers experience afterward is smoother idle, better acceleration, reduced hesitation, and even small but noticeable gains in fuel efficiency. With ignition optimized, the next step is ensuring the engine learns your driving habits, not the habits of the previous owner who unknowingly programmed the computer. Trick number 6, the throttle body cleaning manufacturers treat as dealer-only service. When a vehicle is new, throttle response feels sharp and effortless. A light press of the pedal delivers smooth acceleration, and the engine idles with almost no vibration. But as the miles accumulate, most drivers notice a gradual change: hesitation during takeoff, unstable idle, or a slight stumble when stopping at traffic lights. Nothing dramatic enough to trigger a check engine light, just a subtle decline in refinement that owners often assume is normal aging. What's actually happening is far simpler. The throttle body is slowly accumulating carbon deposits. Modern engines rely on a precisely metered airflow path past the throttle plate. This plate constantly adjusts position to regulate the amount of air entering the engine. Over time, vapors from the PCV system and recirculated exhaust gases leave a thin film of oily residue on the inside of the throttle housing. Dust and combustion byproducts stick to that oil, forming carbon buildup that restricts airflow and interferes with the throttle plate's ability to open and close smoothly. Eventually, the engine computer struggles to maintain consistent idle airflow, and the vehicle begins running less efficiently. Dealerships almost never recommend servicing the throttle body until symptoms become severe enough to justify an expensive cleaning procedure or throttle body replacement. It's not because cleaning is complicated. It's because performing it yourself exposes how unnecessary those costly repairs really are. The process takes only a few minutes. Remove the intake tubing, spray a designated throttle body cleaner onto the carbon deposits, allow it to loosen, then gently wipe or brush the buildup away. Once reassembled, the change is immediately noticeable. The idle stabilizes, throttle response becomes sharper, and acceleration feels smoother and more direct. Cleaning the throttle body once a year prevents unnecessary performance loss and avoids the slow decline many drivers mistakenly interpret as normal wear. With airflow restored, the next weak link to address is the sensor responsible for measuring that incoming air. And when it's dirty, the computer receives false information, leading to wasted fuel and sluggish performance. Trick number 5, the MAF sensor. Cleaning manufacturers avoid mentioning. Every modern fuel-injected engine relies on a mass airflow sensor, the MAF, to determine exactly how much air is entering the engine at any given moment. That measurement influences fuel delivery, timing, throttle response, shift patterns, and even emission system behavior. When a MAF sensor is clean and functioning properly, the engine runs efficiently with the ideal air-to-fuel balance. But when the sensing wire becomes coated with dust, oil vapor, or microparticles from the intake stream, the sensor can no longer read airflow accurately. This results in a richer lean condition that gradually robs the engine of power and efficiency long before a warning light appears. Most drivers never realize this is happening because the decline is subtle. Fuel economy begins dropping, idle quality becomes inconsistent, acceleration feels slightly muted, and the transmission may shift earlier or later than expected. Dealerships frequently diagnose these symptoms as normal or recommend replacing the sensor entirely, a repair that can cost well over $100 depending on the model. Yet mechanically, nothing is actually wrong. The sensor isn't failing, it's simply dirty. Cleaning a MAF sensor requires almost no mechanical skill and only a few minutes of time, but it must be done correctly. The key is using a spray formulated specifically for MAF components, not brake cleaner, not carb cleaner, and not compressed air. Those products can damage the fine platinum wire or film inside the sensor. With the ignition off, disconnect the wiring harness, remove the sensor from the intake, spray the sensing element thoroughly, and allow it to air dry completely before reinstalling. No scrubbing, no touching, no forcing. Once cleaned, many drivers notice an immediate improvement: smoother idle, clearer throttle response, renewed acceleration, and fuel economy, returning to what the vehicle achieved when it was new. MAF cleaning once every oil change is enough to prevent richer lean mixtures, reduce carbon buildup, and extend sensor life dramatically. And now that airflow readings are accurate again, it's time to unlock even more performance by improving how easily the engine can breathe. Trick number 4, the high-flow air filter. Upgrade manufacturers, hope you never compare. If you've ever replaced an air filter, you may have noticed how dense and restrictive the factory paper filter material feels. That isn't an accident or a random design choice, it's intentional. Automakers design factory air filters to prioritize cabin comfort and noise reduction, rather than airflow efficiency. A quieter intake system produces a smoother, softer sound during test drives, and that silent first impression translates into more sales. The trade-off is subtle but significant: reduced airflow, slower throttle response, and a slight dip in power that most drivers never question. When engines can't breathe freely, they can't operate at their full potential. The throttle body, MAF sensor, injectors, and ignition system may all be functioning perfectly, but airflow restriction alone can make the engine feel dull or sluggish. It's not that the engine is weak, it's that it's being suffocated by a filter engineered for sound control rather than performance. A high-flow air filter replaces the thick, restrictive paper element with a more advanced medium, often an oiled cotton or synthetic mesh, that allows substantially more air to pass through while still filtering debris effectively. The difference is measurable. Many drivers report noticeably sharper throttle response, smoother acceleration, and even modest improvements in fuel economy once airflow becomes less restricted. In some cases, the improvement is significant enough to shorten 0 to 60 acceleration times, or eliminate the hesitation many vehicles exhibit during quick throttle inputs. Dealerships rarely mention high-flow filters because they last far longer and don't require frequent replacement. While a standard paper filter is replaced every 12,000 to 15,000 miles, a high-flow filter can be cleaned and reused for the life of the vehicle, saving money on replacements and preventing premature airflow restriction. This simple upgrade allows the engine to inhale the air it was designed to use. With breathing improved and measurement corrected by the MAF cleaning, the next step is to restore fuel delivery precision, because even perfect airflow means nothing if the injectors aren't delivering fuel in the correct pattern. Trick number 3, the fuel injector deep clean method dealerships rarely offer. Fuel injectors are responsible for delivering a precise mist of fuel into the combustion chamber. When they're working correctly, the spray pattern is fine, even, and smooth, allowing for complete combustion and efficient power delivery. Over time, however, injectors experience varnish buildup from fuel additives, ethanol blends, and microscopic impurities. The spray pattern slowly shifts from a finely atomized cone to an uneven stream or partially blocked pulse, affecting idle quality, acceleration, fuel efficiency, and throttle smoothness. The change happens so gradually that most drivers assume the engine is simply aging rather than being restricted. Dealerships often diagnose this issue as injector wear and recommend full replacement, which can cost anywhere from several $100s to well over $1,000 depending on the vehicle. The reality is that most injectors are not worn out, they're just dirty, and a proper cleaning restores their performance. The problem is that the most effective cleaning method isn't usually offered to the public because selling replacement injectors is far more profitable. A deep injector clean doesn't involve pouring a bottle of fuel additive into the tank and hoping it helps. Instead, the cleaning solution is run directly through the fuel rail with the fuel pump temporarily disabled. The engine runs solely on the concentrated cleaner for several minutes, dissolving varnish deposits on the injector tips and restoring the spray pattern. As the cleaning occurs, the engine may idle roughly or briefly smoke, which is normal. Once completed, the improvement is often immediate and noticeable. Smoother idle, quicker throttle response, restored power, and fuel economy returning to original levels. The key is using a high-quality detergent-based cleaner designed for rail-fed service, not a general-purpose additive. Performing this process once every 30,000 to 40,000 miles prevents performance loss and avoids unnecessary injector replacement. With fuel delivery restored and airflow optimized, the next bottleneck to remove is one most drivers overlook entirely, because correcting it requires going slightly outside the manufacturer's comfort zone. Trick number 2, the tire pressure performance adjustment manufacturers don't advertise. Most drivers assume that as long as the dashboard doesn't warn them about low tire pressure, everything must be fine. The reality is far different. The number printed on the driver's side door jamb is not a performance setting, it's a compromise. Manufacturers choose that value primarily to meet comfort goals, ride softness, and noise targets during test drives. The softer and smoother the car feels when a customer first experiences it, the higher the chance of a sale. Performance, responsiveness, and fuel efficiency take a back seat to showroom comfort. But here's the part most people never hear. That recommended pressure is calculated for a fully loaded vehicle, 5 passengers, a full trunk, and possibly additional cargo weight. In real-world driving, over 85% of trips involve one person or two at most, meaning the vehicle is operating significantly lighter than the pressure specification assumes. Under those lighter conditions, the manufacturer setting effectively leaves the tires slightly underinflated. Underinflated tires flex more, create rolling resistance, reduce steering precision, dull acceleration, and slightly decrease fuel economy, all without triggering a TPMS warning because that system only activates after a much larger pressure drop. By increasing tire pressure 3 to 5 psi above the manufacturer recommendation, within the safe limits printed on the sidewall, drivers often notice a meaningful improvement almost immediately. Steering becomes sharper and more direct. Acceleration feels smoother, braking distance improves, and tire wear becomes more even. Fuel economy can increase modestly as well, because reducing sidewall flex lowers rolling resistance. Thousands of drivers who have tested this adjustment report measurable improvements in responsiveness and efficiency without compromising safety. This adjustment isn't about exceeding the tire's safe capacity. It's simply tailoring pressure to normal, lighter driving conditions instead of the theoretical, fully loaded scenario manufacturers use for certification. Once traction and responsiveness are restored, there is one final technique that ties everything together. A driving habit that removes carbon, restores lost power, and keeps the engine performing like it should have from the beginning. That brings us to the final method. Trick number 1, the high RPM Italian tune-up that revives engines manufacturers avoid explaining. Over time, many engines begin to feel slightly dull, lazy, or tired, even when maintenance schedules are followed. Acceleration loses sharpness, throttle response becomes muted, and the engine no longer feels as eager as it once did. Most drivers assume this is simply aging or mileage catching up, but in many cases, the problem isn't wear at all. It's carbon buildup caused by years of low-temperature operation, short trips, and gentle driving habits. Modern engines run lean and clean for emissions purposes, but they also produce small amounts of soot and residue during cold starts and light load conditions. If the engine never reaches full operating temperature or never experiences sustained, higher RPM operation, that residue gradually accumulates on piston crowns, intake valves, spark plug tips, and inside the combustion chamber. Manufacturers do not openly discuss this buildup, because acknowledging it would force them to recommend more aggressive driving, which conflicts with fuel economy messaging and legal liabilities. Instead, they quietly offer expensive dealer services such as induction cleaning or walnut blasting once symptoms appear. However, long before those procedures become necessary, there is a simpler method mechanics have relied on for decades: the Italian tune-up. This process is straightforward. Once the engine is fully warmed, take the vehicle onto a highway and maintain elevated RPM, typically between 3,000 and 4,000 depending on the engine, for roughly 10 to 15 minutes. The goal is not reckless acceleration or redline abuse, but rather sustained heat and airflow. At those temperatures, carbon begins to break down and burn away, restoring proper airflow dynamics and combustion efficiency. The first time this is performed, drivers may notice brief smoke or a stronger exhaust smell, both signs the deposits are burning off. After 1 or 2 sessions spaced a week apart, throttle response typically sharpens, idle smooths out, and lost power returns. Performing this occasionally keeps the combustion chamber clean without chemicals, equipment, or dealership intervention. With this final technique, you now hold the same maintenance strategies experienced mechanics use to keep vehicles running powerfully for hundreds of thousands of miles. Not because the manufacturer said so, but because real results prove it. You've just learned the same 10 techniques mechanics quietly use to keep their own vehicles running stronger, smoother, and far longer than the average driver ever experiences. None of these tricks are complicated, and none require advanced tools. But they all challenge the idea that the factory knows what's best for the long-term life of your engine. Manufacturers design maintenance schedules around marketing, warranties, and regulations. Mechanics design maintenance around what actually keeps a vehicle alive. If you apply even a few of these techniques, you'll notice the difference in how your car idles, accelerates, shifts, and responds. Apply all of them, and you'll likely add years, and possibly hundreds of thousands of miles, to your vehicle's lifespan. If this helped you take control of your car's performance instead of depending on dealership advice, hit that like button, subscribe, and watch the next video on your screen. Your engine will thank you.